Hello, I'm Sytse. I work at Unified Streaming in Amsterdam, and I'm really excited to talk to you about something we've been working on called dynamic server-side content stitching for personalized streams. Now, content stitching in personalized streams isn't anything remarkably new. It's already been done in a lot of custom players, but it pretty much ends there because you have to do a custom player build. You can't really support it across a wide range of devices and like TVs or set-top boxes and that kind of thing. So it becomes very interesting when you put it to the server side. That way it's player agnostic. So I'm just going to dive right into it. This is how we approached the challenge of doing server-side content stitching. And we can see here on the right, the SMIL origin. This is responsible for just generating a playlist. It doesn't do anything very special in that regard. And remix is where this playlist gets resolved, the content gets stitched together, and there's other attempts to make gaps disappear in the timeline. Unified origin uses this newly created playlist, and it will package to a playout format, and optionally it might send it to the transcoder to fix any fragments that may cause playback problems. Now, this is fully stateless, pull-oriented, and scalable. It's very important that there are cache layers between these different components because some of these operations are quite expensive. So we would always want to cache so we can reuse it for any subsequent requests. So if we look a little bit closer at the SMIL origin, we just use the Smile markup language. It's a very easy way to represent media presentations. And here we can just see Here we can just see a sequence of 2 videos, pre-roll and a content. We can also do some cool stuff like specify ranges of the clip. So here we only want 30 seconds of content. And there's also a special meta tag in the head with output description. Now this is more of intention to when we start ABR track matching, we want to match everything to the main content. And this will become more apparent in the next slide. So remix is where the real magic happens. This is where we resolve the SMIL playlist and we start doing track matching. And APR track matching is not as simple as it looks because there are a lot of factors to take into account when you're concatenating different tracks together. How do you make sure that the quality will remain very stable throughout different pieces of content? And you can really write a scientific paper about this using machine learning or whatnot, but we just took a really simple approach. What we did was we just used a penalty-based system. So we looked at the differences between resolutions, bit rates, aspect ratios, and we compile a kind of penalty list, and whatever has the least amount of penalty, that's the most ideal track to match to. So after we've done this matching of ABR tracks, we create another MP4 file. And this MP4 file is a representation of the different pieces of content. And most importantly, it uses dereferenced data. So usually you can just self-contained data into one file. But what we do here is we just dereference the data. We just point to the external pieces of content. And this is very important because we can cache this MP4. This MP4 is only a couple of megabytes big, so we can cache it and use it subsequently. Of course, there's also the challenge of gaps in the timeline when you concatenate tracks together. It's very often the case that between video and audio tracks, they're not really of the same length. So once you're trying to concatenate it together, you get these gaps, and these will really just break players outright. So what we do is very simple for the video side. We just adjust the video frame timings to make sure that they align to a certain point. With audio, it becomes a little bit more tricky because audio, you can't just change the length of an audio frame, but you can fill it with silent audio. So we really just want to pad the content. We don't want to cut into anything, but we just want to preserve everything and just add silent audio or just change the video frame timings to resolve these timeline problems. Now with this MP4, we use this in the unified origin. So here we can finally generate a manifest or a fragment for a specific playout format. And it also so happens that once you're working with content, you don't really know what kind of format the content may be in. If you have, for example, 4:3 video followed by 16:9 aspect ratio video, this can break a lot of players. The players might just start stretching the video and it's going to look awful. So at that point, we can offload this fragment to the transcoder and to just fix this fragment before we serve it. An important step is that we convert video sample entries to AVC3, because instead of collecting all the unique codec configurations and making sure that it all have unique IDs, and then we have to patch every single different piece of content to make sure they reference to the unique IDs. Well, we just converted to AVC3, which means we will do an in-band signaling of video configuration. So before every single iframe of a video, we just insert a codec configuration, SPS, PPS, and we don't have to think about any more patching. So finally, we can apply some DRM and then package it to whichever playout format. The transcode is the piece I've really been working on. We were thinking a while about how we can create a transcoding service that's scalable. And we came up with this kind of solution where we thought of how do you request a transcode operation? Well, what we thought is we're just going to have a payload of 2 MP4s concatenated together. One MP4 is just a description of what we want it to be versus a description what it is. So this gives us all the information we need. Everything in the MP4 container format will give us the information we need on what kind of codec profile we want and other data. Also, we create a hash of this payload, so any subsequent transcode operation will just be cached. Now, in this example, we have a 16:9 video that we want, but our source is 4:3, so this is going to get stretched in the player. The transcoder will add some cropping, centering, add black borders, and subsequently return it to the origin for playout. If you want to know some more, you can head over to our demo page. This is where we showcase the remix and various different use cases. Of course, you can always email me, and even better, just come see me today if you have any questions. My colleague Will is also here today to answer any questions. Thank you.